All right, welcome to problem 17 on the Unit 1 review, where we have to determine if the statements are true or false. These are really popular in the AP test. Say like, which of the following are true, 1 and 2 only, 1 and 3 only, etc. So let's look at item 1, f of 0. Does f of 0 exist? Well, I can see that the function is 1 if x is 0. So yes, f of 0 does exist. Number 1 is true. All right, item 2, the limit as x approaches 0 exists. Well, we know to determine if the limit exists, we have to check the limit from the left and the limit from the right and all of that. If we plug in 0, we know the actual value is 1. But let's think about what this looks like. So the graph of f looks like x squared plus x over x, as long as x doesn't equal 0. So it's kind of doing its thing, and then when it gets to 0, oh, there's a hole, and it changes to the value 1. But that doesn't mean that the limit doesn't exist, right? That just means that there's a hole there. So let's see what happens when we plug in 0. For the x squared plus x over x part of the function, we get 0 over 0, which means we've got to do some work. So let's factor here. Give myself some room. All right, x squared plus x over x can factor to x times x plus 1 over x. My x's cancel, and I get x plus 1. And if I evaluate that at the value, that's the symbol for evaluate, straight up and down bar. If I evaluate that at 0, I get 1. So the limit does exist. We were able to find it. All right, that's wonderful. So number 2 is true. All right, and you can kind of see this is sort of leading me through how to prove if a function is continuous. These are the things that I would expect you to do if you were being asked to prove a function is continuous. Evaluate it at the actual value, find the limit, and if it is continuous, then the limit and the actual value should be at the same point. There shouldn't be a break in it. So the graph is not actually doing this, right? Because the actual value is 1 and the limit is 1, which means the hole has been filled in. All right, so 3, f is continuous, x equals 0. That is also true because f of 0 equals the limit as x approaches 0.